All right, so we're still going to continue on here with lesson 8.2. Don't be surprised when we stay in this chapter for a while because there's a lot of stuff in it. We may end up spending the whole month of April kind of going through the majority of this chapter. Yeah, it's a big one. So today what we're going to do is solving equations with polynomials on both sides. So today's date is the 5th of April. So basically we're going to combine what we did yesterday, so distributing and collecting like terms, with what we did solving equations. I can't even remember when we did it, how long ago it was, but it was a while back, the one that used the equation card. And so that's going to be the whole premise, is to figure out what the variable equals. Now, as you've noticed when we've been doing this math, we didn't always just end up with a's. We ended up with a cubes and a squareds and so on and so forth. So this is going to look a little bit strange, but I think it'll all work out. So let's go through a problem together, and then we'll write down some reminder steps, and then we'll do another problem. So directions would just say something like solve. And so our problem is not a simple one. It's going to be complicated, like, bless you, the questions you were asking me about from homework last night. So 2a times the quantity 5a minus 2 plus 3a times the quantity 2a plus 6 plus 8 on the outside equals a times the quantity 4a plus 1, and then plus 2a times the quantity 6a minus 4, and then outside plus 50. So both sides, I have two sets of distributing, so a total of 4 sets of distributing. I'm going to be combining like terms, and then I'll eventually be able to try to get everything on one side variable-wise and constant on the other. So let's see how this all works out. So we're going to start. 2a times 5a. Well, 2 times 5 is 10. A times a is a squared. 2a times negative 2. Signs are different. 2 times negative 2 is negative 4. And then there's the a. Next, I'm going to distribute a positive 3a. Positive 3a times positive 2a is a positive 6a squared. Positive 3a times a 6 is a positive 18a. And then there's an 8. And then we're going to distribute a. So a times 4a is 4a squared. A times 1 is a. Then we're going to distribute positive 2a. So 2a times 6a is positive 12a squared. Okay. And then 2a times a negative 4 is a negative 8a, and then we have a plus 50. Okay. So first thing, just like what we did when we were solving equations, is we're going to look for like terms on a side and combine them. So I have a 10a squared and a positive 6a squared for a total of 16a squared. I also have a negative 4a and a positive 18a. Signs are different, so I'm going to subtract. Bigger number is positive, so I get positive 14a. And then there's the random plus 8. So we're going to simplify each side first. This was one of the things I noticed you guys really didn't want to do, but I'm going to guarantee you this is going to make life a lot easier. Okay, then we go to the other side, and I think you might see something interesting happen. So I have 4a squared and a 12a squared for a total of 16a squared. And then we have an a and a negative 8a. Signs are different, so I'm going to subtract. Bigger number is negative, so I get negative 7a. So remember, when I'm combining like terms, I'm doing, and then there's the plus 50. I'm doing whatever math it tells me to do. I don't do inverse operations when they're on the same side. And nothing happens to the variable. Okay, so what do you see that's kind of interesting that's going to make this problem easy to deal with? Joey? Yeah, there's a 16a squared on both sides, because if it didn't cancel out, then we would have a polynomial with a second degree that we would have to figure out how to factor, which will come up, but not to the end of this chapter. So that we're not ready to do. So should have some luck here that when we now try to get like terms together by subtracting 16a squared from both sides, they are going to cancel out. So that's going to leave you with 14a plus 8 equals negative 7a plus 50. So notice now, when I'm taking things opposite sides of the equal sign, that's when I do opposite operations. So now I want to get the a's together, so I'm going to add 7a to both sides. That gives me 21a plus 8 equals 50. Well, now I need to get the constants together on the right, so opposite operations. I'm going to subtract 8 from both sides. So that gives me 21a equals 42. And then the last step is to divide both sides by 21, which very kindly, a equals 2. Okay? So, wow, yay, it worked out. That's good. Okay, so I'm going to switch to the next screen. Everybody ready? Sure. Natalie, you good? Yeah? Jackie, you good? Okay. So what we're going to do is write down what we did. So what was the first thing we did in that problem? Distribute. Number 1 is to distribute, to remove parentheses. We did this before, except for when we did it in the past, we only saw a variable to the first degree and we saw constants. So now we've just kicked it up by adding a variable of the second degree at times, okay? So distribute to remove parentheses. So one of the most important things is watch your signs. So one of the things I don't know if you guys have paid attention to is as I'm going through the math, I'm constantly saying, okay, I've got a negative 4 times a positive 2 that gives me negative 8. That is what I am saying in my head. And I'm going to suggest that's exactly what you're saying in your head. Like when I try to teach Tiana spelling words and she's missed some, so I say, okay, you need to write them 4 times each. I said, but I don't want you just to write them. I want you to say the letters as you're writing them. And every time she's done that, she's learned how to spell the word. Because it isn't just her writing it down. She's now cognitively thinking about the letters that make up that word. It's the same thing, okay? So what I'm trying to model to you is what should be going on internally. There's a lot here to watch out for. All right, so we distributed, we removed parentheses. What did we do next? We combine like terms. And I'm going to write on each side. There may be like terms on the left of the equals. There may be like terms on the right of the equals. So we're going to take care of what's on each side to consolidate. Then what did we start doing? Inverse operations. Okay, so then we would do inverse operations. And this is our goal. Let's see, variables on the left. And constants on the right. Now, what inverse operations will we be using when we're getting a squareds together, a's together, constants together? Subtracting or adding. So these two operations, the only two that you would use here would be adding or subtracting. What's the next step? And hopefully the last. Yeah, we're going to solve for the variable. And what math took place then? Okay, it was division at this time. Now, it could be, if it's a fraction, it could be multiplication. Okay, so here's what's interesting. If you guys still have that equation card, this is exactly what the equation card said. Okay, so we haven't done anything differently, except for we have different numbers. All right, you guys ready to do one on your own? This one's not going to be so bad. Okay. So I'm going to have you guys try this one on your own. Let's do 2x times the quantity x plus 4. That plus 7. That equals the quantity x plus 8 plus 2x times the quantity x plus 1 plus 12. What's your problem, Michael? So here we go. Magic of freezing. I distributed on the left side, got 2x squared plus 8x plus 7. I distributed on the right side, got x plus 8 plus 2x squared plus 2x plus 12. I simplified the right side. The left side was already simplified, so I ended up with 2x squared plus 8x plus 7 equals 2x squared plus 3x plus 20. And I chose to write it on the right side in standard form, okay? Then, looking as if it was one step, I did 3 steps. I subtracted 2x squared from both sides to get the x squareds together. I subtracted 3x from both sides to get the x's together. I subtracted 7 from both sides to get the constants together. Now, when we did our example, the original one, I did those in separate steps. But you guys can do it as one step. Okay, you can do it as one. That gave me a total of 5x equals 13. Divide both sides by 5, and I get the answer is x equals 13/5. Notice x is part of the answer because x is what we're solving for. Now, if you changed it to a mixed number, you would have had x equals 2 3/5. I didn't hear anyone give me that answer, but I did hear the last answer, x equals 2.6. Okay? So, how many people ended up with the correct answer? Okay, now, what I heard were people very close, just making a calculation error. So that's something to look for, is where did you make your calculation error? Philip? Honestly, I would stop at x equals 13/5, because if you wanted to check your work, which this would be very challenging to do, not challenging, but time-consuming, the first thing you would do is change it to 13/5, because dealing with the decimals, most people make mistakes, so putting back in the fraction would be and the high school tends to say, yeah, give it to me in that improper fraction form as long as it's reduced to lowest terms, because when I see people go from 13/5 to a mixed number to a decimal, I see mistakes. And the high school, I don't know where their stand is on partial credit. I may know better. I'm going to go to the 8th grade team is going to the high school. No, the whole math department is going to the high school, and we're going to go shadow in classes. And so we may find out. They may say either you have the right answer or you have the wrong answer. I don't know how they actually do their grading, to be honest with you. So I may find out some more. But again, they've told me in the past 13/5. They're happy with that. Okay? All right, one more challenge. Here we go. This one's not as bad. D times the quantity D plus 3, that minus D times the quantity D minus 4 equals 9D minus 16. Okay? All right. Solve that one. All right. When I distributed, I got D squared plus 3D minus D squared plus 4D. And then on the right side, there was nothing to do. I noticed I had 2 sets of like terms on the left side, so I connected them. That's another way to kind of help your brain with the work, is draw connectors. And I noticed that D squared and negative D squared were opposites, so they canceled out. And then 3D plus 4D was 7D. So now I have 7D equals 9D minus 16. I subtracted 9D from both sides to get the variables on the left. That gave me negative 2D equals negative 16. Divided both sides by negative 2, and that's how I got the answer was D equals positive 8. Really easy to make one simple sign error and change the answer, okay? So that's what you guys get to work on homework tonight.